Today's topic is going to be simplifying radicals. Before we can begin, let's review what a radical is. Most of us understand this symbol. It's one we've used throughout math, and for us it means square root. It means the number underneath is a number times itself. That's how we got the square root. So let's go take a look at some basic radical operations. Here we're multiplying radicals. Since both of these terms are square roots, I can multiply what is underneath each square root by each other. Therefore, I would have the square root of 36. 36 is in fact a perfect square. Since 36 is a perfect square, I can take its square root and I am left with a positive 6 or a negative 6. Let's take a look at B. This one's a little different. In A, we did not have a coefficient. We have to treat the coefficients as something separate. So we are able to multiply our coefficients by each other because they are both on the outside. So 5 times 4 is 20. I then can multiply what is under my square root symbols. 2 times 32. That is going to leave me here with 64. Let me change that color so you guys can see that. So we'll make it a background. If we take a look here, what this is saying is I have 20 times the square root of 64. 64 is an actual perfect square root. So I can take the square root of 64 so that I end up with 20 times 8. Therefore, this is 160. It's 20 times positive 8. Oops, and I put that behind it. I should be in front of it, which gives me a positive 160, or 20 times negative 8, which gives me a negative 160. Let's go and work on the steps to simplifying square roots. Feel free to take notes as we move through this next one. So both square roots that we just simplified were perfect square roots. Well, how can I simplify a square root that's not perfect without a calculator? Sorry, let me just make sure you guys can see everything. For example, the square root of 80. Here's where you're going to want to take notes. Feel free to pause as we move along if you need to jot something down. Our first step in order to simplify the square root of 80 is to start with a factor tree. We start with 80. I need to think of two factors that give me 80, and it can be any two factors. I chose 10 and 8. I then need to think of the factors that will give me 10 and the factors that will give me 8. So I chose, 2 and 5 and 2 and 4. In this step, I circle my prime numbers. 2 is a prime number. 5 is a prime number. A prime number can only be found by multiplying 1 and itself. 4, however, is not prime. So I must break that down to 2 times 2. I can now circle those. Once every branch, and what I'm talking about a branch is your lines. Once the end of every branch is circled, you've completed your factor tree. Our next step is to write each prime number under the radical sign. Just like this. Now that we have it written out, our next step is to make pairs of the same number. In this case, I have a pair of 2's, and then I have a second pair of 2's. This 5 does not have a pair, so he's just going to hang out here. After I've made my pairs, I need to pull out one number from each pair, and I'm going to place that number I pull out in front of my radical. So here's my one number as a 2, and then my other pair of 2's comes out as one number. The 5's not coming out because it did not have a pair. Once I've pulled out, I multiply all numbers outside together and anything left inside together. This leaves me with 4 on the outside and 5 on the inside. So the square root of 80 is 4 times the square root of 5. Let's take a minute and review our 4 simple steps. To simplify a square root, I make a factor tree. I then write each prime number under the radical. I circle pairs of the same number, and I bring out one of each pair in front of the radical. Finally, I multiply everything on the outside together and everything on the inside together. Let's go try 2 together and see how we do. Our first problem is the square root of 160. I know that is not a perfect square root. That tells my brain I need to do a factor tree. I'm going to start with the factors of 16 and 10. I then am going to break it down to 2 and 8 and 2 and 5. I'm going to circle both my 2's and my 5 because I do know that they are prime numbers. Since 8 is not, I'm going to break that further down to 2 and 4. I'm going to circle my 2, and then I'm going to break it down to 2 and 2. I notice every branch has come to a stop. I'm now ready for step 2. I'm going to write all my prime factors underneath my radical. I'm going to circle pairs that are the same. This 2 does not have a partner to circle, nor does the 5. So I'm going to bring out one of each pair outside so that I have 2, 2, 2, and 5. Notice I have in between them a multiplication symbol because I'm going to multiply 2 and 2 on the outside to get 4 and 2 and 5 on the inside to get 10. So the square root of 160 is 4 square root of 10. Let's try the square root of 63. Most of you probably decided to do 9 times 7. 7 should get on it a circle since it is a prime number. I'm going to circle my 7. 9 is not, however, so I need to go down to 3 and 3. I'm going to circle 3 and I'm going to circle 3 like so because those are prime numbers. Now that I notice every branch has a circle, I am ready to go write it underneath my radical. 3, 3, and 7. The only pair I have here is 3. Therefore, I bring it out as just 1 3 to get 3 square root of 7. Now is a good time to pause the video and try these on your own. Okay, let's see how you did. Here are our answers. The square root of 72, if you broke your factor tree down, I chose 2 and 36. You could have picked any factors of 72. Our steps should look the same here at this point if we both factored it completely. Notice you have a group of 2's and a group of 3's. Those will come out as 1 each. I then multiply what's on the outside to get 6 square root of 2. Let's go over to my 12, and I will show you what I mean by circling as you come down. There are other factor pairs of 12, but I chose 2 and 6. You have to know what a prime number is. 2 is a prime number. 6 is not, because I can come up with another factor pair of 2 and 3. When I break it down and I put it underneath my radical, I get 2 times 2 times 3. There's one group of 2's, so I should have 2 square root of 3. I hope you're getting a hang of this as we go through it. What happens, however, when I introduce variables into my formula? The rules for simplifying with variables is the same rule as numbers, except you don't need to do a factor tree. We would just write out each number however many times they're there. And I pull out one variable for each pair of variables. Let's see what that looks like for this. I have the square root of 54 n to the 7th. I'm going to need to do my factor tree for 54. It should look somewhat like this. When I go place it underneath my square root symbol now, the number process stays the same. If you take a look, I still write them the same way. Here's where your variable comes into play. My problem said n to the 7th, meaning I have 7 n's that I am multiplying by each other. So I write out n times n times n times n times n times n times n. Make sure that there are 7. When I go through and I do my groupings, I end up with 3 groups of n. Again, pull out just as you would pull out your pairs of numbers and leave what's on the inside. I always put the multiplication symbols in between until I've actually done that work. I finally end up with 3n cubed times the square root of 6n. Let's take a look at B. You guys ready? While it might look a little bit more challenging, there's just one extra step that comes into play now. If you take a look at our problem here, there is a number outside as well as inside. Remember from our previous examples that I'm going to treat those as coefficients, and I'm going to multiply what's outside by each other. If you'd like to, you can also multiply the 7 times the 14 to get 98, and then you can do your factor tree with 98. I personally jumped to placing it under the square root. I knew the factors of 14 were 2 and 7, and I knew 7 was prime. I also have to write out 3 t's because there's a t here and there's 2 t's here. Now I'm ready to make my pairs. I still bring out the same way as I did in my previous example, except this time when I bring something out, there was already a 6 outside. I have to take that into consideration. So finally, when I do this, I would have 42 times t times the square root of t squared. You guys think you're ready to try it on your own? Let's try these 4. Pause the video now. Okay, Let's see how everybody did. These are the answers to A through D. We had already talked about simplifying the square root of 80 in our earlier part of this video. And we had gotten 4 square root of 5. The only thing added to this problem was our variables. We have a negative m outside and 9 inside. The 9 inside allowed me to make 4 groupings to take out 4, but I had 1 here already, and it left 1 inside. On part B, what you could have done to start was multiply the 6 times the 18 to get 3 square root of 108. You then would have broken down the square root of 108 and brought out a 6. 6 times 3 is 18. On part C, if you multiplied your 2 first, you should have gotten 18, a to the 4th. A 3 and an a squared comes out, leaving only a 2 inside. Finally, on D, we actually had a perfect square root. The square root of 100 is 10. The square root of x to the 6th is x cubed. So 21 times 10x cubed is 210x cubed. We have one more question to attempt, and this is putting it into a word problem, a real world situation. So let's read our problem. A rectangular door in a museum is 3 times as tall as its wide. What is the simplified expression for the maximum length of a painting that fits through a door? Before I send you off to attempt this on your own, let's think about a door. Most paintings, we would have to kind of turn on its side to actually get through the door. So think about a rectangular door, and you'd have to turn something on its side, on its diagonal, to get through. I'm going to give you one expression. When in doubt, draw it out. Let's attempt this one. Pause the video now and try it on your own. All right, here's our problem. Like I said, when in doubt, draw it out. If you take a look at our door, I had talked about turning the picture on its side. Well, that ends up creating a right triangle for us. Meaning I know my 2 legs, and I'm looking for my C for my Pythagorean theorem. Here's our formula, but we have to be careful with this. When I go and I replace my B value, I need to use parentheses. Because what I'm doing is I am squaring 3x, meaning I am doing 3x times 3x. That gives me 9x squared. I then am combining my like terms of 1x squared plus 9x squared to get 10x squared. I am taking the square root of each, and then when I simplify down, I get x square root of 10. That is the maximum length of the painting that can fit through that particular door. If the Pythagorean theorem was a bit confusing for you, there is a video on the YouTube channel that you can go to.